Alrighty folks, this is Miss Kwong over here. Today we are going to talk about factoring using reverse box distribution. Here's the do now. Make sure to copy this in your do now section. You may now pause the video to copy and make sure to also do the problem. This is your table of contents. Here's the do now. Let's go over it. So, what do you think the original distribution problem was given x squared minus 7x? Now, if you think back to yesterday when we factored by GCF, we know that the GCF here, if we look at the numbers, right, the greatest common factor is 1. Now, if we look at the variables, the greatest common factor is x. So the greatest common factor I can factor out is 1x. If I divide it out from each, I am left with x minus 7 on the inside of the parentheses. So this is what the original distribution problem was using factoring by GCF. If you were to distribute that out, you would get back to x squared minus 7x. That's how you would check. Okay, so let's do a quick throwback. How do we expand this expression, x minus 7 times x plus 3? Now if you remember from the last unit, we can either use the box method or the distribution method. The box method is where you label the x minus 7 and x plus 3 on the sides of the box. The distribution method is to break it out, right? X minus 7 is going to be multiplied with x. X minus 7 is also going to be multiplied by 3, each part of this second binomial. Now if you distribute that out, multiply it through, you should get this. X squared minus 7x plus 3x minus 21. Box method gets you the same exact thing. Okay, so we would write our final answer like this, right? And then we would simplify. It's the same thing for either method. Now, today we're talking about something different, but very similar. What if we only gave you this information, just the information in green? How would you figure out what the original problem was? Well, that's what we're going to talk about today. So, the method to do that is to factor the GCF of each row. So we're doing the same process that we did yesterday, but now we're going to split it up into two different problems. So this is the same slide as previous, right? Where we had the box method and we got this solution, or we did the distribution method and got this. Same exact information, but on this slide. We're going to split that information up in half, right? So what we're going to do is we're going to find the GCF of each row. We're going to find the GCF of x squared minus 7x, okay? And that, from the do now, gets us x times x minus 7. And we're going to find the GCF of the second row, right? Giving us 3 is the GCF. Let's write this out. Okay, so here, if we factored it out, we get x times x minus 7. That's the same thing. This is the same expression here. So we get x times x minus 7 using GCF. Okay. Now treat the second part as also a separate GCF problem, right? The GCF here is 3. Is 3. Now the variables, if you look, this has an x and this doesn't have an x. Okay, so it's just the GCF is 3. So I'm going to factor out a 3, and then I get x, right? 3x divided by 3 is x. Negative 21 divided by 3 is negative 7. Right? That gets us, this is the same process here. We're just factoring by GCF. And what that shows us is actually what the original distribution problem was, right? The original distribution problem was, well, we take this, they both have x minus 7 in common. I'm going to change this color to green. Now I'm going to change it to blue. So what our final answer is we're going to take these GCFs, right? And we're going to write that up as one factor. So we know x plus 3 is part of the distribution problem. right? And they both have x minus 7. So x minus 7 is the second part of the distribution problem. Same process here, right? Plus 3 times x minus 7. Now that's exactly what the distribution problem was. Right? What we did was we used GCF in order to get reverse there. We did the reverse box. We did a reverse distribution, right? So we factored each of these sections using the reverse box and the reverse distribution method. So basically what we're doing now is just like Jeopardy. Okay, we're giving you the answer, just like in Jeopardy, to give you the answer. We give you what it is after you distribute. And what we want you to figure out is, what was that original problem? We want you to figure out, well, the original problem was x minus 7 times x plus 3. Just like Jeopardy, if you watch it. Okay, so here's another example. X squared minus 8x plus 7x minus 56. Okay, so the very first step in the reverse box method, or the reverse distribution method, is to fill it out, right? So I'm going to plug it in, each of those terms into the box, right? If I want to prefer the box method, do that. If you prefer the distribution, you can write it out and then just use a little line, split it down the middle. Same process, right? That's the very first step. Okay? Secondly, the second step is to factor out the GCF of each half of the expression. So I'm going to factor x squared minus 8x using GCF. That gives us x times x minus 8. Okay? And then I'm going to factor out the GCF of 7x minus 56. Well, that GCF is 7. And then I'm left with x minus 8. Same process in the reverse distribution. Right? I split it down the middle. I'm factoring x squared minus 8x, giving us x times x minus 8. I'm factoring out the 7x minus 56, factor out a 7. And I get 7 times x minus 8. Okay? In the box method, now that tells us if I'm factoring out an x from the x squared minus 8x, I'm going to put an x in this part of the box, right? If I factor out a 7 from the second expression, I'm going to put a 7 right here. Take a look at how that works out, right? We just figured out what that original distribution problem was. So our final answer is to write out that product, that binomial product, x minus 8 times x plus 7. Right? Same thing for reverse distribution, x minus 8 times x plus 7. Okay, you may pause it, you may review it, replay it if you'd like. Now to check, you would just double distribute and see if it gets you back to this original problem. And it does. Okay, let's do another example. Now you try. 2x squared minus 10x minus x plus 5. Go ahead and try this on your own. Pause this video. You may choose either the reverse box method or reverse distribution. Not both, just one. All right, great. So the very first step in factoring this polynomial is to first fill in those 4 terms, either in the box or write them straight out. If you're using reverse distribution, great. Second step is to split it up. Split it in the middle so you know which 2 factoring problems you're going to be doing for GCF. Right? So in the box method, I like using a dashed line. So I see that I'm factoring this top piece, and then later I'm going to factor this bottom piece. In the reverse distribution, use a line and split it down the middle. So you know you're factoring the first half, and then you're also going to factor the second half separately. Now to factor, we need to use GCF. So I'm going to use a blue color marker here. In this first part, to factor it, I need to figure out the GCF by first looking at the numbers. Right? So 2 and negative 10. The GCF there is going to be 2. Right? And then my GCF for the variables, x squared and x, is going to be x. So I know 2x is going to be my GCF. And then when I factor out that 2x, right, then I'm left with, and I'm just going to write it up here. It's going to show up on the bottom later. So I'm going to be left with 2x times x minus 5. I divided each term by the 2x, and I was left with x minus 5. Now the second part is to factor the second half. Okay, so here, if you notice, in front of this x is the number -1, right? That negative sign without a number just means the coefficient is -1, and the number here is 5. Okay. Now, when the first coefficient in our factor, in our expression, is negative, we're going to keep that negative. Okay, so first let's look at what is the greatest common factor of 1, right, and the greatest common factor of 5. Well, that greatest common factor is 1, right, and then because this first coefficient in this expression is a negative, I'm going to keep that negative with my GCF, right, and if I factor that out, negative x divided by -1 is x, positive 5 divided by -1 is -5. Just like I did in this box method, you're going to be doing the same thing here, right? You're going to factor this chunk, GCF is 2x, times, and then you're going to divide out the 2x from each term, leaving us with x minus 5. And same thing here, right? The GCF is -1, and then when you divide it out from each, you get x minus 5 remaining. Here's what it looks like written out when you factor them out. And then, if you notice, the final answer, right, you take the GCFs of each of those expressions, and then I put them on the outside of the box here on the left. And then what's in common, the x minus 5, goes on top of the box. So my final answer is x minus 5 times 2x minus 1. In the reverse distribution method, it's the same process. Notice how the 2x minus 1 ended up going all into one expression. And then the common factor, x minus 5, that common binomial, just concentrated down to 1. So we have an x minus 5 times, and then you put the common factors in a set of parentheses, and you get 2x minus 1. That is the factored form of this original polynomial. Double distribute to check. So now take time to practice, right? The timing might be different, but try to get as much practice as you can. Start with number 1, go through number 12. You can do just the odds, just the evens if you feel like you're getting the hang of it. And we also have a level 4 practice that you can do. Okay? Pause this video so you can get the practice done. And then go ahead and now check your answers, give yourself a score, see where you're at. It's possible I might have made a mistake here. Make sure to flag me down for that. But if you want to double check, remember double distribute. See if it gets you the original problem. You can pause the videos to check your answer. So a quick summary from today are these steps, right? So how do we figure out the original problem? In the reverse box method, in the reverse distribution method, it's very similar. In the reverse box method, you're just putting in all the terms into a box. In the reverse distribution, write it out, right? Then use a line to split it down the middle so you know exactly what two pieces you are factoring to get to our final answer. So first, put all 4 terms in the box. In the reverse distribution, split the 4 terms with a line down the middle. Okay? You pick which method you prefer, one or the other. Secondly, in the reverse box, you're going to factor the GCFs for each row, right? Just like we did in the previous problems. In the reverse distribution, you're factoring the GCFs for each side. Notice how it's the same exact problem, right? Just written in a different way. And then lastly, once you've factored out the GCF for each row, right, you should find that there's a common factor, right, from each of them. And you're going to write them as a product of 2 binomials. And that was the same process here. So in our previous example, the solution here was 2x minus 1 times x minus 5, 2x minus 1 times x minus 5. If you're stuck, rewind, go back to the other parts of this video, pause as you need, right? Use the examples to help you. You do not need to go through all of them, right? And then go ahead and do the practice. Good luck.